So good afternoon, everybody. This afternoon I'm going to talk about scheduling, and I'm going to give a lecture, and then we're going to schedule some sessions, some VLBI sessions. But right now I wanted to show you the master schedule for intensives, and this is on the IBS website, which we looked at the other day. And if we look at December 7th, we see this session here, EDU 231. And if we look at the stations involved, it's Fortaleza, Hartreo, and Betzel. And the time of the session is 1400. But that's not 1400 Brazilian time, it's 1400 UTC. UTC is universal time, and that is a time we use in VLBI because everybody has different time zones. So when you schedule something or you talk about something, you always schedule it in UTC. I'm involved in at least one meeting a week where I have people from Australia and China and Shanghai. And usually these meetings start at about 6 o'clock in the morning, my time, because that's the only time that works for everybody. Jean-Pierre, are you going to talk about going out there, or about transportation, or who's going to talk transportation?
I think my husband will do, but it's simple. 2 p.m. UTC is 11 o'clock here, so the bus is scheduled for 9 a.m., right? So 9 you arrive there 10 a.m. So during 1 hour we will have a visit at the observatory, and at the end we will explain to you what will happen at 11 local time, 2 p.m. UTC. Okay? That is 1 hour duration session. And then back to here on the afternoon classes of 2 p.m. local time.
So the bus leaves at 9 o'clock here.
Assim, bom, o importante é que o pessoal que estará no ônibus entende. O pessoal de dentro dos ônibus.
Aplicar um microfone com uma caixinha de som lá no fundo, professor.
Tá bom. Mas tá ok? Só para lembrar disso, tá? E na hora das perguntas, isso sim, uma mensagem que eu recebi do pessoal lá online, na hora das perguntas, é bom falar mais alto, e eles não escutam as perguntas.
Ok.
Tá bom? Obrigado.
Okay, can you, Max, can you help me start my PowerPoint?
Okay, let's go.
Okay.
Alt tab, eu just need back to Chrome and change the stop screen, share screen, and select the PowerPoint slide.
Yes, okay.
Share. Okay. Let's go back.
So I'm going to talk about how to schedule a VLBI session using Sched. This presentation will be about an hour or so, and then we'll probably break for tea, and then we'll come back and we'll do some sessions. Now, in order to understand this, you need to have some general understanding of VLBI, which at this stage you guys all do. And my goal is so that you guys understand how to schedule a session, and you have some understanding of SCED. So SCED is a software program that was written a long time ago and that I currently maintain. And after this, we're going to, as I said, make some simple schedules. So we've seen this slide a dozen times so far, and this just shows that VLBI. And in VLBI, you have the same antennas, where you have 2 or more antennas looking at the same source. And because of that, VLBI has to be cooperative. People have to work together to get it done. You know, I've been in this community for 40 years, and I have to say that the VLBI community is generally very friendly. Everybody works together. Especially, we like to help new people get started. So, we've seen the IVS master schedule before, and it tells you everything you need to know to schedule a session. The kind of session, the start and stop time, what stations are there, who is responsible for scheduling it, who is going to correlate it, who is going to analyze it, and the status. Now, this schedule that we're talking about was actually scheduled at NASA. It's going to be correlated at Bonn, and we'll analyze it together next week. Here is a picture of the master file. Each line of it corresponds to a single session, and it tells you what stations are involved, how long the session is. If you look at Ops Center over there, who is responsible for making the schedule, etc. There are 2 versions of this. One is a version with HTML links, and another is just an ASCII file. This schedule is generated at NASA, but at the coordinating center, and then it's updated frequently. And then here is a session web page. If I drill down on a particular session, it'll give me information about that session. Before a session starts, this page does not have much information on it. The first thing that will happen that you see on here is the schedule file, because the schedule file gets posted before the session starts. Then once the session runs, more information gets put on there. Then we also have pages for each station, and they give you an idea of what sessions the station is going to be involved in nearby in the current time. Now, you don't need to do scheduling software. You can do it yourself, but it's very complicated, and this takes care of a lot of the stuff. So the scheduling software has models of the sources. It has models of the antennas. Each of the antenna moves at different speeds. There are different kinds of antennas. It also knows where the antennas are located, and the equipment at the station. The equipment at station varies from station to station, and that influences the schedule. Now, one of the things you have to worry about at stations is something called cable wrap. And you have the equipment, which is downstairs, and then you have a feed, which is upstairs, and the antenna is rotating. And you have cables that go up to the feed, and as the antenna is rotating, the cable rotates around. And it can't continue to rotate, or you'll break the cable. So at some stage, you have to come back again. Most antennas have some region of overlap. So here is a picture of the cable wrap system of an antenna, and this has a range of 540 degrees in azimuth. Here is a picture of the cable wrap at Onslaught. And you can see up at the top, there's this place where there is an overlap. So this is the antenna is pointing in azimuth. And all of these plots I have here, the top axis means you're pointing north. So if I have two sources at Onsala, and I want to go from one to the other, if I'm in this part of the cable wrap, then there's only one way to go. I have to go clockwise. But if I'm in this part of the cable wrap, then there are two possibilities to go. I can go either clockwise or counterclockwise. And SCAD will try to go in the shortest direction, which in this case is counterclockwise. Sometimes you have situations where one source is right near the end of a cable wrap, and then you have to look at which direction the source is moving, because it can happen that the source will go from one part of the cable wrap to another. Another problem you have is if you're moving 180 degrees. And SCAD always assumes that the antenna will move in the shortest distance, but the antenna hardware may have slightly different interpretations, particularly if you're close to 180 degrees. So we try not to schedule observations there. There are a variety of scheduling programs. I'm going to be talking about SCED. There is SHED, which is used by astronomers, mostly. There's VSHED, which is an older program, and there's VSHED++. VSHED++ is a very nice program. A lot of the modern schedules are being scheduled using this. I don't know how to run it very well, so I'm not going to talk about it. The SCED files are ASCII files, and there's two different versions of that. One is the SKD format, and one is the VEX format. And they both have the same kind of information. They're just presented differently. So here is the SCED data flow. We talked about the master file, which describes the session. SCED also has catalogs, and the catalogs have information about the sources and the antennas. And SCED, when it starts off, and you tell it what stations you're going to use, it reads this catalogs. Then you make a schedule, and the schedule is sent to the IBS data center, and then it's sent out to the stations and the correlator.
One question.
We do use data automation for lots of things. We mostly use Python scripts and cron jobs. So the question was, do you use data automation using DevOps methodology to automate and integrate the many geosource data and many equipments out there? So the answer is yeah, we do, and we're moving towards that. So we talked about the master file. We have two kinds of master files right now. We have one master file for the 24-hour sessions and one for the 1-hour session. And earlier this caused some confusion because the site manager at Fortaleza was looking for the session and he didn't see it because he was looking in the 24-hour master file, but it's really in the 1 hour. And then there are the catalogs. And there's one catalog for each kind of information. So you have catalogs about the station positions, antenna parameters, electronics and recorders, etc. Now, a schedule file will contain everything you need to run the session. And it also contains the information needed to regenerate that session if you want it, if you're curious about how it's done. The schedule file is used by the scheduler, he makes it. It's used at the stations, it's used at the correlators, and it's used by the analysts. So here is what a schedule file looks like. It has different sections that start with this parameter's $sign. This particular schedule file is for a session R1875. Then there is a param section which has information about how the schedule is set up. There's also information here about when the schedule was created and which software created it. And then downstairs, further below, there are other parts of it. Now, as I said, there's two formats. The previous was a SCED. This is a VEX format, and it has the same sort of information in there. It just is differently formatted. The VEX format is the more modern version, and we're moving towards that. So here is a list of the major parts of a schedule file. Mostly you don't need to look at this, but you can look at it if necessary. And we will look at it when we're doing our exercises. Now I want to talk a little bit about some terminology. We have a site, and at a site we have one or more VLBI antennas. Like Fortaleza is a VLBI site. Right now they have one VLBI antenna, but they're going to have another VLBI antenna. And a station is a VLBI antenna together with all of its equipment. We talked about what a source is. Usually it's a quasar, but you can also observe spacecraft or satellites. And a scan is when you have two or more VLBI antennas observing the same source. An observation is the two antennas looking at a source. Then we have subnetting. I'll explain this in a little more detail. So here I have a network of 5 VLBI antennas, and 4 of them are looking at one source, and the other one is not participating. So these 4 antennas are participating in a single scan. They're all looking at the same source, but this scan has 6 observations because I have the delay between station 1 and station 2, the delay between station 2 and station 4, the delay between station 2 and station 3, etc. So I have generally many more observations than I do scans. So here's just a table where I derive the general result. If I have a n station scan, I have n times n minus 1 over 2 observations. Subnetting happens when I divide the network into 2, and one part of the network observes one source and another part observes another source. Now, if you have a global network, there's a good chance that not all of the stations can observe all the sources at the same time. So you have to divide the sky into pieces, and sometimes you'll have like northern stations will be observing there, southern stations observing there. Then you'll have eastern stations observing here, and western stations observing the other direction. So that's why you have subnetting. Here is a chart which we looked at before, and this is a calculation of the SNR. And the SNR depends on the strength of the antenna, or the sensitivity of the antenna, the strength of the sources, and the number of bits you're recording. The number of bits you're recording depends on the bandwidth, and how many channels you have. In SX, we typically have like 16 channels, and then on how long the scan length is. Usually we want to have an SNR of 15 to 20 to assure that we detect the source, and that we have adequate margin if something goes wrong. So if you want to increase the SNR, there's only a few things you can do. You can look at stronger sources, you can have more sensitive antennas, or you can increase the number of bits. So the ideal source is strong, it's compact, and there's no source structure. Goddard, our VLBI group periodically reviews a list of sources to come up with a list of recommended sources for people to use. So here is a picture of a good source at two different frequencies, at X band and at S band. And this image was made by Bordeaux University. And here is a picture that shows sort of what the noise is in the delay measurements that you get from that. And the RMS is, on one side is about 0.84 picoseconds, which is not bad. And on the other side it's about 0.7 picoseconds. So there's not a lot of noise caused by the fact that the source has some structure. Are you going to get this side? Here is an OK source. You can see that it has more source structure. Pardon? Well, some of this stuff is noise, but you see the elliptical shape of that? That's real. And that is due to the jets. These things have jets going out. And here is the same sort of thing, a map. The RMS is about the same. It's not a lot. Sorry. We go back. Okay, and if you look at this plot here, I see the RMS is about 4 picoseconds at S band and about 23 picoseconds at X band. So this is introduces a lot of noise in our observation. And here is a bad source. This is a source that we won't typically observe because it will corrupt our measurements. And here's just pictures of it. You can see there's a lot more stuff happening. So here is some information about where you can find pictures of these sources and regular stuff. Now, each of the sources has a strength associated with it, and we want sources that are strong. So here's a histogram of the sources showing how strong they are. And generally, you have more sources at weaker levels. The plot doesn't show that, it sort of dies off, but partly that's because we don't go down that far. So we like sources that have a flux density of about 0.25. So here I just go through an example of how you calculate the SNR. You don't need to worry about this too much because SCED will do this for you. But on this particular source, if I observe for 50 seconds, I'd have an SNR of 11, which is too low. I really want something that's higher, an SNR of about 15, which means the integration time has to be 90 seconds. So, what's a good schedule? Well, a lot of this is empirically based. Some of it is obvious, but one is the more observations, the better. You want to have a lot of observations. At each site, you'd like to have a minimum of 10 to 12 scans per hour. And the reason you want this is because you have variation at the atmosphere. The weather changes at the atmosphere, and you want to be able to follow that. And you need to have about 10 scans an hour to do that. You don't want to have gaps in the scheduling. You don't want to not observe a station for a long period of time. You also, and this means that, the station is observing for some period of time, then it's not observing for an hour. The other thing you don't want is idle time. And this is slightly different. And one of the things that happens is that when you schedule an observation, you have all the antennas will move towards this source. And some antennas will get to the source first, and then it'll take time for the other antennas to get there. So this one antenna is just waiting around for its friends to come. So that's like idle time. You'd also like the observations to be evenly distributed over the sky, over some period of roughly an hour. You don't want to just observe in this one part of the sky. You want to observe, you have the observations here, 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 so that they're widely spread. You also like to have some low elevation scans because that helps you differentiate between some parameters. Here's just a brief history of SCED. I'm going to skip this. And here is, as I said, the SCED user manual. This is available online. I showed you on Monday how to find it. This gets updated periodically as we put new options into SCED. This has descriptions of all of the SCED commands. It also has a cookbook for making schedules, examples of how to make a schedule starting from start to finish. But I'm going to show you how to generate schedules myself. So, SCED itself, it's a text-based program, and you enter in a command with arguments and you get something back. Like in this example here, I've entered in the word SNR, and it tells me, returns to me the aggregates. So this is saying on, for example, on the Onslow and the Allison baseline, I want to have an SNR of 25 for my observations at X band and of 15 at S band, etc. You have different ways of specifying the time in SCED, and here I just give different ways of doing it. You can specify the year, the day of the year, and the time, or you can just specify the hour, minute, second, and it will try to figure out what it is. There are also some special commands for time, like now, which means the current time, the begin, which is the start, begin or start, which is the beginning of the schedule, or the end. So these are used, for example, you can say, I want to schedule something from now to the end of the session. And here is just a list of some of the most frequently used SCED commands. There are about 200 of them. There are commands to list the schedule, commands to check the schedule, a command to summarize, which is useful to just see, get summary information about it. You can see what stations are in the schedule, what sources are, etc., and so on. Finally, at the bottom of it, there are commands to write out the schedule and to quit. So here's a picture just showing how you start it and what it looks like. So you say SCED, and then you give it some file, and that's the schedule file. And then it will read in the schedule file and tell you information that it finds in the schedule. So in this particular scan, the schedule, it found 659 scans and 60 sources with 7 stations. And then it keeps on going and giving you additional stuff, and then finally it will tell you what the first scan is in the schedule. If you want to know a list of the SCED commands at any time, you can just type in a question mark, and they'll give you a list of all the commands together with a very brief description. For all the commands, if you type question mark and then the command name, it'll give you more information. And for the newer commands, you can type command and then question mark, and you'll get a lot more information. So here's just some examples. I am listing the, I say list dot, which means the current time, and it tells me what the current scan is. The SCED's looking at the file, it keeps a pointer of where it is in the schedule. The next command is, I'm asking it to list scans between the beginning time and 1710. And each line it lists there is a different scan in the schedule. So if I look at the first scan, this has, let's see, 5 stations that are observing and 2 of them that are not. It tells you for each of the stations how long they're observing for. And you know, if you look at the second scan, I have the same sort of thing. If I look at the third and fourth scan, I have an example of subnetting, where I have some of the stations are observing one source and some are observing another. At the end of a schedule, I might be interested in seeing what sources were observed or information about the schedule generally, and you can look at that using the summary command. And here's an example of how to do it. And this is just a plot showing which source was observed at which time during the schedule. So that's sort of what this X's are. And at the right-hand side of this, it will tell you how many scans the source was observed in and how many observations. And if I go down further, it gives the same sort of information for the stations. Now, and these are in 15-minute blocks. Now, I told you earlier that you don't like to have a station not observed. Sometimes there are good reasons for a station not to observe. And in this particular example, I have Verão is off for about an hour. And the reason it is off is because Verão was participating in an intensive session. You know, we talked about intensive sessions this morning, and so Verão participated in this 24-hour session, then it took a break to participate in the intensive session, and then it came back. And the summary command just gives some more information here. It tells you, if you look at this, how much observation time in percentage, how much calibration time, how much time the antenna is spent slewing, and the idle time. It does this on a station-by-station basis and on an average. So for this particular schedule, only 44% of the time was spent observing. The rest of the time was spent calibration or slewing or waiting. One of the things that you can do in SCED is you can do a sky plot. So this is, you can do that using the summary command, and this just shows you the observations at each station. And ideally, you would like the sky plots to have uniform sky distribution, like the ones at Matera and Nielsen at the bottom. Sometimes you can't have this because of network distribution. Sometimes you have a case where a station cannot observe, or in some parts of the sky it can't observe with other stations. There's a command to select stations, and it brings up this the screen here, and you just use your cursor to go around, and you highlight a station, and then you can add that to your schedule. So this lists each of the stations, the equipment there, the kind of recorder there, and what bands it's observing at. So here's how you generate a schedule, sort of a step-by-step. You choose the stations that you're going to schedule. You do this by looking at the master file. You choose a frequency setup, the frequency sequence. And by this I mean what frequencies you're going to observe during this schedule. And you set the start and stop signs, and you choose the sources. Once you've done the first 4 steps, you're ready to begin scheduling. So you schedule a scan, and then you keep on repeating this until you run out of time. So this is like the manual mode of doing it, which nobody does anymore. Here is another sched command where I'm listing the stations, and it just gives me a list of the stations in this schedule and information about them. There are other commands to select the sources or the frequencies, and they work just like the station. So here's as I said, if you want to schedule things by hand, you can do it. But most of this is, in the US we have this phrase for plug and chug, is that you have numbers and you just have to do the calculation. So it doesn't take a lot of intelligence to do it. And Sched will do most of this stuff for you. So in the old days, you had to do everything by hand. Nowadays, you can just set up the schedule entirely with one command. And when I first implemented this, people were complaining that it made the scheduling too easy, because it used to take like an hour to set it up, and now it takes 20 seconds. So there are a couple of commands you can use. One is master check. And what master check does is it will check your schedule against what is in the master file. And it will make sure that things agree. And this is important because sometimes people will make mistakes in generating the schedule. And master check they might have stations that they might have missed a station, or they might have stations that were not in the schedule, or their stop and start times may be wrong. And master get is the command that reads the master file, and then it reads in all of the information from the master file to set up the schedule. Sometimes when it's reading the master file, it doesn't have the information it needs for how to set up the schedule, and it will issue a warning message. And mostly this has to do with your SNR targets. So it tells you this message that some of the SNRs baselines have 0 SNR, so you need to adjust them. Okay, so here is a cookbook for generating an R1 schedule. So you copy a schedule, you start with a schedule that already exists, and then you rename it, copy it to another file, then you open it up. Then one of the things you have to do is you have to change the session name. Previously we started with R1412, so now I'm changing the name to R1413. Then you use the master get command to initialize the schedule. The next thing I want to do is I want to select the best sources for this session. And the sources that Sched uses, the best sources depend on the network. For example, if you have a network that has just northern hemisphere sources, it doesn't make sense to have southern hemisphere sources there, because they're not going to be used. Downtime is a command which is used to say, don't observe some stations during this time because they're doing something else. This is usually used for intensives, but occasionally it can be used for other purposes. We've had some cases where some antennas participated in observing spacecraft, and so they weren't available for 15 minutes here or there. So we can say, turn them off for that period.
Teacher, the last part, yes, Gibson or N or A?
Pardon? Show me. Oh, you're doing this yourself, huh? Say yes.
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 Okay.
Yeah. Okay, so then I set the downtime because of the intensives. And then I say auto underscore end. And that will just go ahead and make the schedule. And this whole process takes 30 seconds or so. Lastly, what I usually do is I use the sum command to examine it. The command WR means write the schedule out, and then quit means quit. So two kinds of scheduling. One is manual mode, and one is automatic mode. In automatic mode, Sched determines everything. In manual mode, you can specify some stuff and have Sched determine the rest. So you can specify a given source if you want to observe some source, and then you can specify other things about it, like when to observe it, which stations to use it, how long to observe. If you don't specify anything else, then Sched will try to figure out what to do. Yes?
Can you go back one slide? So just go to this. No, more. Yes, go.
Okay.
Okay, thanks.
So a typical session has about 1,000 scans, so most of the time you don't want to schedule things manually. You want to schedule them automatically. There are some times when you do want to schedule things manually because you may want to be interested in some specific source. So you'll write a schedule to run for an hour, then you'll put in an observation of the source, and then have it continue running. In automatic mode,
Calculator, teacher.
yes, that's the best command, right?
Okay.
In automatic mode, all you do is you specify the subnet. The subnet means what stations are involved and the end time. So I give a couple of examples of the automatic mode. One is where I specify some subnet, and one is where I just say everything. So I want to then talk a little bit more about sort of the details of the inside about how Sched works. And there are two steps involved. One is determined by things called major options, and this determines what kind of scans we want to consider. At any given time, there are lots and lots of possibilities. I have lots and lots of sources. I have different subsets of antennas, and I need some way of paring these things down. So the Sched starts by generating a list of all the possible scans at a current time, and then it has various filters that it uses. And it will keep the scans that pass those filters. If they don't pass those filters, it will throw them away. Then it does an initial ranking. It will keep scans in the top some percent, 50%, 100%, whatever. Then it ranks them by the minor criteria. Okay, I've just gone through this. So here are some major options. One is the subnet. So the subnet means what stations. So the subnet determines which stations you're going to observe in a scan. Sky coverage means basically how even is the sky sampled. If I have sources which are close together, they have low sky coverage. If I have sources which are far apart, that's good sky coverage. I talked about having the difference between a scan and an observation. And a given scan can have many, many observations or many, many baselines. And You can say if you want all of the baselines to meet the SNR targets, or it's okay if some of them don't. Another thing you can say is, how closely do I want the my observations to be in angular resolution, in angular spacing? Generally speaking, it doesn't make sense to observe a source here and then observe a source which is right next to it. You want to say it has to be at least like 15 degrees or 30 degrees away. Another criteria which is related is, how frequently can I observe the same source? All things being equal, SCEDS likes to use strong sources. And if you didn't put in something, SCED would just keep on going back to the same source over and over again because it likes strong sources. So you have to put in a criteria that says, don't observe the same source more frequently than, say, 10 minutes. Another criteria is min sun distance. And the reason you have this is because you don't want to observe too close to the sun for two reasons. One is that if you observe too close to the sun, the radio signal is disturbed by the solar corona. The second thing is, if you observe too close to the sun, you can destroy the electronics on the antenna. If you point right at the sun, you're going to just destroy everything. So there's a limit on the sun distance. Max slew time is, how long are you going to allow an antenna to slew? You may say that if it takes more than, say, 3 minutes for an antenna to get someplace, I'm not going to consider that. I want to look at scans that are closer. Time window has to do with, if I look at even sky distribution, how long a time do I need that? Minimum subnet is, if I look at schedule scans, what's the smallest net I use? Generally, people say, minimum subnet of like 3. That means I have to have 3 stations observing each source. An exception to this is the intensives, which just have 2 stations. And the number of subnets is, how many subnets do I have at the same time? If I have a 14 station network, I can divide it into lots and lots of subnets, but typically you like to observe more stations rather than fewer. I'm going to skip best fill-in. I'm going to talk about in a second. All of the major options are set by saying major, and then you give the option name, and then you give a value. So here I've set the minimum angle to 30 degrees. So going through this, what I said earlier in another way, start with the universe of all possible scans. I throw away stuff that don't meet the criteria, and then I arrive at some set of sources to consider. Then I generate scans with those sources. I do some more filtering. Then finally I have some limited set of scans that are left. Then I have the scans that pass the major filters. I throw away some of them, and then I go to the minor mode. And the minor options, for each scan, it looks at a variety of characteristics, and it assigns a weight to it. And then it calculates the total score, and it takes this scan that has the highest score. So that's basically it. Most of the stuff you won't need to do right now. Okay, special topic, downtime.
Teacher,
Yes.
so using these comments, you can filter the source and
I'm not sure what the question is.
Using these comments,
Uh-huh.
you can output filter options of the source.
Yes, but yeah. Yeah.
Thanks.
Okay, so as it said, downtime, I talked about this briefly earlier, is you just specify when a station is not going to be available to observe. Another mode that you have in SCAD is fill-in mode. And then when you have a scan, you typically have something like this, in that all the stations move to a source, and then they observe long enough to meet the SNR targets. And then when they're done, they become idle, and they're available for something else. But there I have all this time that I could use for something else. So one thing I can do is look to see if I can schedule another scan in there. And I look at the sources which aren't doing anything. If I can, I schedule another scan, and then I repeat this until I'm done. Okay, another special topic is, sometimes if you have a antenna which is new, you don't want to schedule it in the session fully, because if there's problems with the antenna and it doesn't operate, it can break the schedule. So instead what you do is you can schedule in tag-along mode. And tag-along mode means that it will observe if it can, and if it can't, it won't do anything. But this is just a way of scheduling this session sort of in a trial mode to see if things work. Okay, so that's it for right now. And
Teacher, have you a question?
okay.
Abre a conversa mesmo. Vai lá. Okay. It's the questions.
Okay, so there's a couple of questions. Valdine says, where does the 1.75 correction factor come from? And there's a couple of things for this. One is that part of the factor comes from we digitize the system. We digitize the signal. And when we digitize the signal, we lose information. There are various levels of digitizing it. The simplest is you just say plus or minus. The signal has a value below 0 or above 0. Other ways are you can say the signal is below 0 and high, below 0 or above 0 and high, above 0 and not as high. So you can do like 4-level quantization. And depending on how much quantization you have, you change that correction factor. The other things that come in is that there are approximations made in the correlation that also change it. So Valdine is also saying that Fortaleza has times when it's not doing anything. Probably other VLBI stations have the same thing. And could he use Fortaleza to do research in solar physics? And the answer is, I'm not in charge of Fortaleza. Then there's another question about if lightning occurs, how bad is this to the observation? And I don't know about lightning, but I do know that if you have bad weather of different kinds, it can affect things. Just earlier this week, we had a session which involved VETSEL, and we had problems with VETSEL because there was snow on the antenna. And the signal didn't get through. Another thing that can happen is if you have high winds. Most of these antennas can move up to, I don't know, maybe 50 kilometers an hour, something like that. Or maybe it's 30, but if it's more than that, then the antennas stop moving and they put them in a slew position for safety. The other issue with winds is even if it's not a matter of safety, if there's too much winds, then the antennas are going to be moving around and that's going to affect your observation.
Teacher, I have a question. I'm trying to open the Odyssey observation, and the data not is the archive used, is in binary. How I can open it?
I'm not sure what the question is.
I'm trying to open the Odyssey data
Uh-huh.
in website, but the data is in binary. How can I open it?
It's in this NetCDF format. So you have to write software in NetCDF.
Oh, okay.
Yeah. So the question is, what is the minimum elevation angle commonly used? And the answer to that is it's typically 7 degrees. There are pluses and minuses to go into low elevation. In principle, if you go to low elevation, it helps you determine the atmosphere better. But also the lower elevation you go to, the more the atmosphere is mismodeled. So historically we've said 7 degrees or sometimes 5 degrees in our minimum elevation. The other thing to bear in mind is that at each antenna, there may be objects which are blocking the horizon. Like you might have a mountain over here. And so you can't observe through the mountain, so you have to observe above the mountain in that area. So we have things called elevation masks that say how high you have to observe at each azimuth.
Teacher, what's this variation? Minimum percent 1.5 is because the antenna or the data?
I'll explain that later. It's a little complicated.
Okay.
Okay? Okay. Let's break for 20 minutes
Okay.
and come back and then we'll write some schedules. So
Right.
this thing is want you to take a picture of this because this is going to be, we're going to start doing some schedules together. And so first off, I want you to take a picture of this, and then I'm going to boot into Linux and show my screen under Linux and go through some of these things so that you can follow what I'm doing. So the first thing is, yes?
There is a GitHub with the sched catalogs. We are going to use this for something?
Well, I'm glad you found that, but we're not going to use that today.
Okay.
There's a place where you can download the sched code and install it, and then the catalogs are separate. But okay. So the first thing we're going to do is we're just going to look at a schedule that's already there, an intensive schedule. I'm not sure how many observations it has. I think it has about 20 or something. Then we are going to, starting with that, we are going to make another intensive schedule for January 6th of this year and just see what that looks like. After that, we are going to make the schedule for the session that starts tomorrow.
Okay.
And so those are all simple things. If we have time, I want us to open up a schedule file and modify it by hand and see what the effects are on the schedule. So up here, I've put in part of the schedule file, and the stuff in red tells me the slew speed of the antenna. That is, how fast the antenna moves in degrees per minute. And I just give it for one of the antennas, which is Vetzel. The stuff that is in green tells me how sensitive the antenna is at X band and at S band. So by increasing the sensitivity, making the numbers smaller, we can pretend that we have a more sensitive antenna. By increasing the speed of the antenna, we can pretend that we have a faster antenna. And the goal is to see here, what is the effect on the number of observations? But I'm not sure if we're going to have time to do that or not, but I want this to be up there so that you guys can think about it. And we may return to this next week. So take photos of this because I'm going to get out of this, and then, yes? Okay, all set?
All set.
Okay, so as I said, I'm going to boot into Linux.
You close the transmission.
I'm going to go into Linux, so it's going to go anyway.
Ah, okay. Avisa que ele está reiniciando o computador. Não, mas ele falou depois que fechou. Avisa agora. O professor está reiniciando o computador. Ah, está aparecendo, não é só? Ah, ok. Fechou.
So do you want to try to share this, or can we do it or not?
I'm going. You read my mind. Let's go. Okay, let's go to internet. É o mesmo e-mail, né, Lara? Só o e-mail. Só mostrar aqui. Bota atividade. You need to log in.
I don't know. Let's do Facebook.
Wait a second, teacher. Disconnect the image.
Are those guys? Can people offsite see it or no? I mean, I don't care.
Okay.
Okay. So I'm not sure what's happening.
The screen mirror in data show.
Uh-huh.
So I configure it to not show your Facebook login in data show.
Okay. I don't remember my Facebook login. Let me see. Oh, sorry, I got rid of the page. Can you or somebody else log in?
That was my. Oh, it have your Google login.
Yeah, will that work?
Work.
Okay.
Load, continue, allow. Presence.
I want to share the whole screen.
Let's go. Select the screen. Let's change again. Okay.
Okay, everybody, let's follow along with what I'm going to do. So I'm going to open up a terminal window. And it loads in lots of stuff. So I am going to change directories to do a CD example/sched. And if I do a listing there, I have several files.
Okay.
Some of these are schedule files and some of them are other kinds of files. So let's open up the file i23003.sched. And I'm going to do that by typing sched i23003.sched. So this opens up this file, and it tells me a little bit about what's in the session. I mean, this station has 2 stations. It has 30 scans, and it gives us the first observation there. The first observation starts at 1830. It involves Koke and Betzel, and they each observe for 40 seconds. I'm going to type in LI, just return, and that lists all of the scans in this session. So you can see that some of the scans vary. Some of them are 40 seconds, some of them are 50 seconds, some of them are 160 seconds. Now, it may be that I'm interested in excuse me, what the SNR is of these scans. So I can turn on SNR by typing XL space SNR. And that will tell me then, I also want to know what the SNR is of all of these scans. And if I do an LI now, it will tell me what the duration is, and then it tells me what the SNR is on each of the bands. Are you guys seeing this?
Yes.
Yeah, you got it? Okay. If I type in XL question mark, it tells me what kind of information I can display. So I was just displaying the SNL. I may also be interested in knowing what the pointing information is. So I can say XL as L. So that means I want to know where the as and the L are for this. And if I do an LI now, it has these extra columns here with the azimuth and the elevation of the 2 antennas. So that's just some of the sorts of information you can get out of this. If I want just a sort of view of the overall summary of the schedule, I just type in SUMM, and if I just hit return, it should give me some information. So it tells me about how much time Koke spent and Betzel spent observing. They spent 58% of the time observing, 8% in calibration, and then how, yes?
Which was the last command you put to show this? The last one.
This SUMM.
Okay.
That's like summary. So, you know, this gives me information about this Down at the very bottom, it tells me, if I look at this thing there, how much, what's the space requirement? So each of these stations is going to record 67 gigabytes of data for an hour. Now, if I had a 24-hour session, it'd be, 24 times that, so a couple of terabytes. And then it thinks about the average SNR, et cetera. So this is just looking at this one schedule. And I'm done. Now let me remind myself what schedules there are there. I have what was that? I'm going to copy this schedule to I23006.sched. And so I am going to generate the schedule for January 6th of this year. Now, if I just look at the top of this, I'm just going to do a more, which is sort of like a listing. The first line in there says I23003. So this internally, the schedule file still thinks that it is for the 3rd. So there's two things I could do. I could go in with the text editor and change it, or I can change it within Sched itself. So I'm going to open up the file in Sched, I2300.sched. And then I'm going to change the name of the session. I'm going to say Expert I2306. And let me just I'm going to do a param li all. And that will tell me something about how the schedule is set up. So it gives me the experiment name, but it's going to start when it ends, but it still thinks it's starting and ending on the 3rd because I haven't read the information in from the master file. So I'm now going to do master get. And what this will do is it will read the information from the master file and update everything. Okay. I have this warning message here. It says, some baselines have 0 SNR. Please set. And the reason I have this is because I have a new station in here. I'm not using Coque. I'm using, or not Betzel, I'm using Nealicent. So the stations have changed and it doesn't know what to do. So I need to change the SNR, and I always forget how to do that. So I'm going to type $SNR. And that will tell me how to change the SNR. So I'm going to say SNR underscore means for all stations, X band 20. And SNR underscore S band 15. Now if I do the SNR command, I can see that those are my current SNR targets. The other thing I want to do is I want to select the sources which are best for this particular baseline. And I can do this by hand or automatically. And I'm going to do it automatically. And I'm going to say best 60 to select the best 60 sources. And it goes through and looks at all the sources, does some calculations, and finds the sources that it thinks are best. And if I do source LI, it comes up with the best 60 sources based on that. To generate the schedule, I just now type auto underscore N. So this means automatically schedule it and start using all of the stations to the end of the session. So I type that, and it's generated 23 scans for this. So I can list the scans. So Max, if I want to see the as an L, what do I do?
So
If I want to, this just lists how long the scans are. If I want to see the azimuth and elevation, what do I do?
what I do, what's the Excel?
XL, as L.
You select
And so that will give me the the azimuth and L.
as you tell you give to me the information.
Yeah. Now, SCED has a lot of commands, and most of the time you just use 10 or 20 of them. But at any time you can always put in a question mark. Try that again. And this lists all the commands that SCED has. I said, let's do a summary listing, and we're going to do it slightly different than last time. I'm going to say SUMM underscore 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 LI. So this gives me, starts off here with all the sources, and R and S are the rise and set times, and then X is when it's observed.
Is the position of stars, teacher?
Pardon? This is, no, this is when they're observed, if they're observed during the day. So, for this particular schedule, we had 63% of the time it was observing. And 24% of the time, things were slewing. So the antennas were moving around. Let's see. If you want to, if you type in the command, what's up, then that will tell you what sources are visible right now and at what stations. So in principle, you could schedule any of those sources. You can also get a graphical view of the scans by typing sum underscore 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 poll. So this shows the scans that are observed at Koki and Wetzel. And the interpretation is there should be a circle here showing the sky coverage, but each of these corresponds to a different observation. So that tells you that they're pretty evenly distributed over sky. Okay. So I'm going to quit out of here, and then I want you guys to, based on just what I did, there is this edu231.sced. That is the session we are observing tomorrow. see if you can generate the schedule for that. edu231.sched. So that stands for educational. It's an educational session.
Another file.
Huh?
I used another file.
You used another file, okay? Oh, yeah, but this is what we were just doing, right? So as I said, get out of this and try to generate a schedule for
Edu 231.
231. Yeah, sched space.
Edu. Ok. Pergunta, pode fazer. Have a question picture in chat.
Okay.
Tira a foto da tela. Ah,
As text appear on the horizon, does the VLE search proceed to the next source on the list for all antennas automatically?
Can you take a picture of it and show me?
Deixa assim.
So Veldon asks, as the sources disappear over the horizon, does the VLBI search proceed to the next source on the list for all antennas automatically? Yes, it will go through all of the source lists and see what sources are up right now. So at any given time, only some of the sources are up. So I hope that answers the question.
This one is the observation we are going to do tomorrow, right?
Yeah, uh-huh.
Okay,
Good.
thanks.
Okay. So now you guys can all get job scheduling VLBI schedules.
L, as Is that teacher?
That looks about right. Uh-huh. Okay, get out of this schedule and let's open up another schedule. Let's open up R11,000.sched.
11,000.
So this schedule is a 24-hour session devoted to measuring EOP. So one question, how many stations are in this schedule?
14.
14, yes. And in the back, what's your name?
Me, Eric.
Eric. How many scans are there?
983.
Do you have it up on your machine?
I'm looking right now.
Okay. So you can see here then we have 14 stations here, so a lot of stations. And I am going to look at the first 10 minutes of this. And So I type up li caret, which means from the beginning, and then I'm going to look at 10 minutes. So this gives me an idea of what the schedule looks like. If I look at this, I see that there's a lot of variation. In some stations observe for just 20 seconds, some stations observe for 100 seconds. If I do a summary listing, SUMM underscore 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 LI, this shows the sources that are in the schedule, and you can see that the sources are observed much more frequently. And if I look down at the stations, I see that the stations are observed pretty consistently over this 24-hour period.
Teacher, why did not send me in this angle?
Okay, so here's a good question. I have the number of observations per baseline. So if I look at the first line here, I have a Bidari to Hartreo. So that's 175. But that would also be the same as Hartreo to Bidari. So this is symmetric about the diagonal. So I don't need to display the stuff on the lower diagonal. It would be exactly the same information. So I observe with it on a baseline, and so if I call the baseline Bidari to Hart or Hart to Bidari, it doesn't matter. It's the same information. So here I just organize things alphabetically, and I tell you what the thing is from Bidari to Hart. But if I looked at the other way, from Hart to Bidari, I'd also have 175. Do you understand now? So this also gives other information like how many of my scans were 2-station scans or 3-station scans, etc. Oops, I got rid of
Excuse me. Here is LI, this one is 17000. What else?
put in 170010.
Come. 010. Enter.
Uh-huh. Oh, put a space between the LI and the first.
Okay, thank you.
Veldon says, could you repeat the last procedures? Was it a time-restricted input? I'm not sure what he's asking about that. Maybe it was the listing when I was giving a small listing, asking for a sub-listing.
Teacher, why the SNR is completely another graphic?
Did you type in the SNR thing?
Yes.
Okay, so the SNR, if you type in SNR, it gives the SNR targets, and it also does it on a baseline. So in this case, I don't know, for some reason it's lower triangular as opposed to upper triangle, but it's exactly the same.
Very interesting.
So let's look at the plot of what the observation looks like. Sum underscore 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 poll. So here you can see that there's lots of plots here because I have 14 stations. I only can have so many information on each plot. If I look at some stations like Noto, there is this hole here. And the reason is there's no place that Noto can observe. There's no partner that Noto can observe with in that direction. If I look at places like Bidari is in Russia, so it can observe people in all different directions, which is why the distribution is more uniform.
Another trick, you can use the multi-window. Excuse me. Aqui. Select. And select. Now you can change the
Yep.
better. Também dá para maximizar. Só fica ruim de trocar no Linux. No Linux fica mais chatinho de trocar. Aqui no Linux fica ruim de trocar.
So this also tells you how many scans we have for each of these stations. So these are roughly 400 scans for a day, or yeah, roughly 400.
The last option.
Last option, okay. And I'm going to get out of this for the time being because I want to go back to ear. So this was for a SX session. If I go up here, I have the total number of scans for each session. On average, it's 391. So that's what? That's about 15 scans an hour. So that's reasonable. It's sort of what we like. I'm going to quit out of here, and then let's look at a Vigos session. And I have a couple of these. I'm going to look at V03124. Sched V03124 .sched. And this has 10 stations. The Vigos network is not as big as the SX. SX we have 40 or 50 stations. Vigos we have much fewer, and there's not as many to choose. And I am going to, let's do a listing, LI space up dash 1800, no, 181000. So this shows me what I have here. This particular schedule was set so that all of the observations were 30 seconds. And this was done because we're just starting to schedule the Vigos sessions, and we are being conservative. I'm going to look at the SNR for this. But I'm only going to do well, let me try that same thing. The problem is I have
My computer's thinking.
the computer's thinking. I messed up. Let me get back in. Okay. I'm going to look at a sky coverage of this thing. So if I look at the sky coverage of these, I see that I have way more scans. Some of these stations have 1,000 scans, over 1,000 scans. And actually, we could probably get more than that. We could probably get maybe even up to 2,000 scans. And the idea is the more scans we have, the better. So there are two reasons we can get so many scans. One is the antennas move fast. And the other is we're observing broadband. So we're having lots of signals so we can observe a shorter period of time. Okay, I'm going to get out of this. And let's try changing the param li all. In the SCED setup, I have the minimum scan length is 30 seconds, and the maximum scan length is 30 seconds. So I have that all of my scans are going to be 30 seconds. But I can change the minimum scan length to be 10 seconds. So I'm going to observe for a shorter period of time. So let's change the minimum scan length to 10 seconds and see what happens in terms of the number of observations. So I'll do param min scan 10. I'm going to delete all of the observations. And then I'm going to do auto underscore end. So it's going through and it's generating the schedule. So I've never done this on the schedule, so I don't know what the results will be. Uh-huh, uh-huh.
The difference.
Yep. Are you doing the same thing I'm doing?
Yes.
Slower computer.
Yes. Second generation E3. I3.
Now, when I was first, many, many years ago, when I was doing Build BI, we would all share the same computer to do runs. And, you know, a conference would be coming up and everybody would be trying to analyze the data at the same time. And there's a way that you could set the priority of runs. So sometimes people would set their runs to have higher priority so that their stuff would get done first. But that's sort of rude. And I and this other guy got into this contest with you wait until the antenna settles down. So in any case, I and this other guy were getting into this sort of fight with setting the priority of our runs higher and higher. And so I gave mine the highest priority. And then I thought, no, this is mean. I want to get back. But I set the priority so high that it wouldn't even read the keyboard. So, okay, so here I did this run and we now had 2,800 scans as opposed to whatever it was before, 1,300 or something like that. Okay.
1,000.
1,000. You'll get there.
Tá no 1.000. A diferença de ser pelo número tá no 1.000. Contando aqui.
So a lot of times what you'll do when you generate a schedule is you'll see problems with the schedule. There might be gaps in the scheduling, and then you have to figure out, why is this happening? What can I do to fix it? So I think that we will wait about modifying schedules until later on, but you can see how to go about generating schedules and how to get some information about them. We've generated the schedule, or a schedule for tomorrow. My colleague at Goddard generated this last week, so it might be slightly different, but it should have about the same number of observations. That data will be shipped to the correlator at Bonn in Germany and processed there and then made available to us. So one of the things to consider is that we write this one schedule, and then you have people in 3 different countries working and taking the data for the good of the community. This session was nothing that we had planned, but when I heard that I was coming down here to teach this class, I said, it would be nice if we scheduled a session and that the students could analyze the data from. And so we contacted the people at these sites to see if it was okay with them, and they all said yes. And so we should be thankful for them to spending their resources on this. Any other questions before I call it quits for today? Okay. Well, then I say buenas noches. How does NASA deal with the SpaceX satellite due to the large number of satellites obstructing? That's an important question, and we're still trying to figure that out. Almost there.
No, 2,000. It's a nice benchmark.
Mine?
190 seconds.
Oh, mine is, so how long is yours taking? Mine is 119, yours is?
Your computer, total CPU time.
Yeah.
Let's see my computer time.
Are you done?
No.
What is it?
If I run my cell phone, must be finished. 5 nanometers versus nanometers.
So Max, what number is it at? What number now? Is it done?
2,720, no, 60, 60, currently growing. Sai, ó, vai terminar, finish, finish,
And how many seconds?
448,
Okay. So you know you can get a cup of coffee.
yes.
Okay, so tomorrow everybody goes to Fortaleza, and we see the antenna working.
Okay.
Já está decidido para ir em Dolores?
Oh, I asked to find more things in my computer.
Já está fazendo o quê para amanhã?
What is it? What's happening?
I asked more things to ask my computer.
Uh-huh.
Let's go some slash oh, enter. É porque a gente tirou esse comando da resposta agora do Google. Jogou esse comando no negócio agora. É porque esse aqui demorou mais. Esse aqui o limite é 2.800 no O outro era mais baixo, que era 20, e entrava lá, entendeu?
So, Valden, what that is that's the observations, yeah, plotted on the different antennas. So, okay. Thanks. Okay.